Hi everyone. So today we are going to solve subarray product less than k, which is variable size sliding window. So let's see the problem, and this is the problem you have, and we are going to solve this today's video. Okay, let's start. I'm going to explain to you what problem says first. Okay, so in a variable size, we follow some steps like in a variable size problem, what we have to do, we just initialize a small window, and according to problem's condition, then according to that problem condition, we will either expand the window or shrink the window. It is depend on the problem. So not for only one problem, like it varies problem to problem. So if you solve uh, decent number of problems, then you are able to find out when we have to expand the window and when we have to shrink the window. Okay, so let's discuss for this. Uh, okay, before going to the question, okay, so let me explain to you question what says. It says, let's say I'm taking example 1, so 10, 5, 2, and 6, and we also given a k is 100. Okay, these things we have given an array and an integer k, uh, which is for example k equal to 100. Okay, what we have to do, uh, we have to find the number of subarrays of that product is less than k. So let's say product of subarray is strictly less than k. So this condition should follow, and we have to count how many subarrays are like this, that are following this condition. Okay, if you see, the subarray is like 10 is the subarray, because if you do the product of all the elements, you will get a 10, and 10 is less than 100. This basically this is following this condition. Okay, and if you take another one, 10 and 5, 10 and 5, this is another subarray which satisfying the condition, the given condition. If you do the product of these two, you'll get 10 into 5, 50, and 50 is less than 100. So this is satisfying. Okay, and if you take a subarray 5, 10, 5, and 2, this one, this subarray, and if you do product, then you will get 10 into 5 into 2, you'll get 50 into 10, 50 into 2 equal to 100. And if you compare this thing, this condition, as you can see, this is not satisfying. Okay, because they are equal, so this is not satisfying, and this is not the subarray we want. Okay, so we don't count this subarray. Okay, there are 8 subarray which is going to satisfy this condition, so I'm not going to discuss. And okay, so what is the brute force approach? The brute force approach is like generate all the subarrays, like 10, then 10 comma 5, then 10 comma 5 comma 2, then 10 comma 5 comma 2 comma 6. Okay, generate all the subarrays 5 and so on. Okay, and do the product for each subarray and compare this thing. If the condition is met, then we will increment my answer, my count variable. Otherwise I'm not going to increment. Okay, so this is the brute force approach. I'm not going to write the code because it's very simple. You just write a two for loop and just do a product for the subarray, and you'll get a product, compare with the condition, and increment that count. So that's it. And the time complexity it's going to take would be big O of n square, because you are going to use two for loop for that. generating the subarrays, all the subarrays. Okay, so let me walk through a concept like if you have elements like 6, 7, and 8, if you already have this, but if you included like 6, 7, 8, and 9, and then after including, how many subarrays you can form after including 9? Okay, so including 9 means we have to include 9. We don't care about 6, 7, 8, 9, but we have to include 9. How many subarrays we can form? First subarray is 9 itself. Okay, then 8, 9 we can form. This and this we can form. We have to include 9. We don't care about 6, 7, 8 either. Okay, so we can form like 8, 9, then 7, 8, 9 we can form. 7, 8, 9. Remember, we need to find subarray, not the subsequence. Okay, so and another one would be 9 and this 6. So 6, 7, 8, and 9. Okay, so and if I have like 9, 10, and 11, I have added 11. How many subarrays we can form? 11 itself alone, then we can form 10 or 11, this thing, this and this, and then we can form 9 to 11, so it would be 9, 10, and 11. Okay, so what is the journal like in this? How many number of elements you have? 1, 2, 3, 4, 4 elements, and in this you have 3 elements, and as you can see, number of elements decide how many subarrays we can form. Okay, so it would be 1, 2, 3, 4. So 4 for this, 1, 2, 3. So 3. Whatever the number of elements we have, then we can form that many subarrays from that. Okay, so this is the concept you have to remember, because in this question it is going to be used. How we are going to use? Let's see in a while. So let me erase this first. Okay, so in a variable size sliding window, we are going to do one thing. We are initializing a window which is very small. So my left pointer is pointing to this index, and my right pointer is pointing to again this index. Okay, this is my very small window. Now I am going to decide on what condition I am going to expand my window and what condition I am going to shrink my window. Okay, so I have to take a product, so I am going to create a variable called product, and initially I am going to initialize with 1. Why 1? Why not 0? Because if you take a 0 and then you multiply with another element, then it becomes 0, so it won't helpful. So we are going to take 1. Okay, so 1 is there. Now we will include this element. Including this element means product equal to product, what is the previous product, and the current element we have included. So previous product is 1, and the 10, the element that we have included, that is 10, so the product is 10. Okay, so we will compare with this, like this is my current window and I am treating this window as a sub array. Okay, so that sub array has a product of 10, and I am going to compare with this k, and my k is 100. So as you can see, this is satisfying. This condition is satisfying. So this window can become our answer. So you have 10 included. How many subarrays you can form? Only 10. As you can see, n equal to 1, that means you can form one subarray from that. Okay, so let's say I have an answer. I have added 1. Okay, now move the window. Whenever the condition is satisfied, I will increase my window. Increase the window. So increasing window means adding element. So adding element means I am going to increase my right pointer. So my window now becomes this. Okay, my right pointer now pointing to this index. Okay, and if you do the product now for this current window, it would be product equal to previous product into whatever the new element added, that is 5, and what is the previous product, it would be 10, and into 5 you will get 50. Now you compare this 50 with this condition, so it would be 50 is less than k. Yes, this is satisfying again. So that means this current window, this current window is going to be our answer. That means this is the subarray who is going to satisfy this. So as you can see, 10 and 5, but this 5 is included, so we have to consider it. So how many subarrays we can form after including this 5? The one subarray is 5 and another one is 10 and 5. One subarray is 5 and another is 10 and 5. So or you can do like a generic formula we have made, that is number of elements we have 2 and how many subarrays we can form is again 2. So I am going to add this 2. Okay, so you can ask like why, uh, if you have a subarray whose product, whose elements, all the elements I am going to product and which is less than k, then you take this subarray of that again subarray, like this is a small subarray, and if you take the product of this product, this elements, this subarrays, then you also get less than k, less than k. So that's why we are counting this as well. I hope this makes sense. Okay, if you don't, then be with me. You will understand eventually. Okay, so now if the condition is satisfied, we have to increase the window. So increasing means I'm going to increase my right pointer. So my right pointer now is pointing to the third index. So it would be this. This is my current window and my right pointer is pointing here. Okay, now we have to calculate the product. So the product is going to be previous product into the new element you have added. What is that? Is 2, and previous product was 2, and into 2 you will get 100. Now compare this 100 with k. Okay, compare this element 100 with k. 100 less than k and k is 100. As you can see, this is not satisfying. This, that means the current window or current subarray we have, this is the current window and subarrays we have. That means this is, we have to count this into our answer. So we don't have to count this into our answer. So that means if you increase, so let's consider if you increase the window. Now what we have to do, if you increase the window, let's suppose you have included this 6 into our window, then the product is going to be increased to increase, it's very greater than k, it becomes high. So again the condition is going to be false, but we want the product should be less than k. So what we have to do, we have to shrink the window. So that means we have to shrink the window, and that will what will do, like this 100, after shrinking the window, this going to decrease. So it may or may not satisfy this condition, but we have to decrease this to meet the condition which is given in the problem. Okay, so let's do. Mm, we have to decrease the shrink the window, so I have to increase my left pointer, so it's going to be this thing. Okay, let me raise. My left pointer is pointing to this. Now we have to decrease this. How we are going to do that? Like in a product case, like if you are doing product, how will you remove this from the product? Just by dividing this with the product. So this is going to be this product equal to previous product you have, and the whatever you want to remove the element. In this case it will be 10. So previous product was 100, and if you divide this you'll get 10. Okay, now you compare this 10 with k. So it will be 10 is less than k, which is 100. Yes, this is satisfying condition. That means this window, this window is the subarrays we are looking for. So how many subarrays we can form? So let's say you have 5 and you have included 2. So this 2 is a subarray, and 5 and 2 is another subarray. So we can form 2 subarrays from this. Okay, 2 subarrays. So we have to include this 2. You can do like the number of elements present inside this subarray is a subarrays that satisfy the condition. Okay, now if this is satisfying, then we have to what we have to do, we have to increase the window. Okay, increasing window means we have to increase the right pointer, and my right pointer is now pointing to this thing. This is my right pointer. Now what we have to do, we have added the element, so we have to multiply this into product. So I'm going to write over here, so product equal to my previous product into the current element we have added, which is 6. My previous product is this 10 into 6, you'll get 60. Now if you compare this 60 with k, k is 100. So as you can see, this is also satisfying. That means this current window can have a sub arrays who is going to satisfy this condition. So we have 3 elements in this, so 5, 2 and 6, and we are going to include this 6. So how many sub arrays we can form with this 6? So a 6 itself, and then 2 6 we can form, and then 5 2 6 we can form. So or you can say like there are 3 elements present and equal to 3. So the three subarrays are going to be formed that satisfy the condition. So it would be 3. Okay, I have added 3 into our answer. Okay, so if the condition is satisfying, that means we have to increase the window. So increasing window, so after increasing the window, your right pointer is now pointing to here, and which is we have crossed, we have exhausted the elements of the array, so we will stop here. Okay, so this is the algorithm we are going to do. So whenever you see a problem which is variable sized sliding window, so we have initialized a small window, then we will expand or shrink the window depending on the problem's condition. It varies like problem to problem. If you solve a decent number of problems, then you are able to quickly click the uh, thing, like what on what condition we are going to we have to increase the window, or on what condition we will decrease the window. So this is the thing. And one more, there is a one edge case we have to discuss, is like, let's say we have 10, 5 and 2 and 6. If we have k equal to 0, that means the we have to find a subarrays product of subarrays which is less than k. And as you can see, the constraint we have given is like nums of I is less than or equal to, so the element nums of I can be belongs to 1 to 1000. So if k equal to 0, that means we never form this subarrays, because if you do any product, then you won't get any 0, because the element lies between 1 to 1000. So we cannot form a subarrays whose product going to give us 0. Okay, similar for 1, if k equal to 1, you cannot form a subarrays whose uh, actually, yes, we cannot form that subarrays whose uh, k equal to, if k equal to 1, uh, then we cannot also form for that a subarrays whose product is less than 1. 1 means, if you do, like, if you are thinking about like what is the case, like array we have given is this 1 and 1, we can form this and this is the subarray and it has a product 1. But read the question carefully, we have to find the product less. Okay, strictly less. That means if we have a product of subarrays, then it should be strictly less than 1. Strictly less than 1. So that means it can be negative values or 0. And in previously we have discussed that 0 we cannot form. A subarrays of product are not going to give a 0 for this, because of this condition, because elements are lying between 1 to 1000. So this is the edge case. So whenever we see like, if my k is less than or equal to 1, then we don't have to go all the code, we just return 0, because we cannot form a subarrays. Okay, so let's go into the code and see. Okay, so initially I'm going to declare an variable which is going to store the array size. So it will be nums dot size. Okay, now we will need a left pointer which is pointing to a small window. So we are going to creating a window which is very small. So left and right pointer deciding factor of window. So left is pointing to 0 and right is pointing to 0. That means both are pointing to 0, and this is the very small window we have created. Okay, now while r is going to n, that means r is going to reach the end first before the l left pointer. So we have to compare this first. Okay, so now we need a product variable initially initialized with 1. Okay, before this we will have to check a base condition, edge case. If my k is less than or equal to 1, then there is no subarray exists, so we will return 0. Okay, so after doing, we have to do product equal to product into the new element, that is nums of right, and while my product is greater than or equal to k, what we have to do? We have to shrink the window. How we are going to shrink? It is going to be shrink pro equal to product previous and the nums of right pointer, and I am going to increase my right pointer. After doing this, we have a sub-arrays who satisfy this condition, which means the product of that sub-array is strictly less than k. So we have to include into our answer. So how? So we will create an answer variable initialized with 0 initially, and we will in how we are going to add answer. So we have a window, and I also told you that the number of elements are present inside that window, that is going to be our sub arrays. How many sub arrays we can form? That many sub arrays we can form. So number of elements. So how we are going to uh, extract, that is r minus l plus 1. So this is the length of the window we have. So that I am going to add, and after that I will increase my right pointer. After this loop end, I am going to return my answer. So this is the code for this. Let's submit this. Uh, See, it's very easy to, but you have to solve very decent amount of question to like to solve to understand whenever you see very unseen problem that you haven't faced any kind of problem, then you quickly strike like this problem is going to solve using variable size sliding window. Okay, so yes, we have done this, and we left with four more questions we have to do, and we will do in the next video. Okay, so thank you for watching.